Here we are having the first speakers. Both are from Gojek. One is Adit Lal and other one is Rushal Irot. Both are Android product engineers working from 6 years and more than 3 years. So let's hear from them. They have something to present. Thank you.
Hello everyone. So today we are gonna talk about better async with Kotlin coroutine. How many of you write down Kotlin coroutine yet? Okay, 1, 2. Oh, more hands from this side, not this side. Okay. Um, so in this talk we are gonna introduce how to write down Kotlin coroutines and what they are used for. Before that, I would like to introduce myself again. But other than I'm working at Gojek, I'm working in Centim currently. Centim is delivering products in Southeast Asia. So.
Okay. Good morning, everyone. Most of you know me, but then I'll still introduce myself. Hi, I'm Adit. I work with Vishali. We work at a company called Gojek. It's an Indonesian-based company. We have slowly going international. We have recently launched in Vietnam. No plans yet for India yet, though. So today we are going to be talking about coroutines, like Vishali already asked. We are also going to be introducing you to coroutines if you've never used it. This talk is going to be a beginner talk. It's not going to be a very advanced talk. So actually, let's see what we do with this particular talk, right? Oh, sorry, can you go back? Yep. Yeah. So in our day-to-day life, we write Android applications. We do something very simple, but we do it in a very complicated fashion. This is a problem statement. If you can read this, you can see that we are going to talk to an API. We're going to do something asynchronously. We're going to get some data from an API, process the data, and then show it on our UI threads. How many of you use RX over here? OK, how many of you can actually give a talk on it or be a pro with it? Oh, nice. Good. One hand. Two hands. Good. So how many of you are actually comfortable using APIs like something like this, where you have annotation threads? OK, cool. So let's actually take a look at, let's break this problem down. Let's actually write it in Kotlin coroutines. So currently we have a very simple API, thread. You can run a thread. You can start a thread. Inside that, you can talk to your API. You can then switch threads, take that data back from that thread, and then move it to another thread, right? As you can see, we have to write callbacks here. The reason for callbacks is because the thread is not as straightforward. It only allows you to do a particular task, and then it gives you the data back, and then you have to take it to your UI. Similarly, we have async task. Async task was the old famous, my most favorite class, async task, where you could do a lot of background work, and it used to crash your app pretty badly. Again, you had to use a lot of callbacks. The block on the right, the gray blocks that you see, are callbacks that you had to write. You had to do a lot of error handling. You had to talk to your UI thread a lot, back and forth, right? Similarly, we had RX. I have not yet completely moved from RX to coroutines. This talk is not about how to bitch about coroutine. It's also about how coroutines can actually help you do things faster, right? Again, here we had to use callbacks because callbacks are still required. The RX solution that you see here is not optimal for our use case. With that,
yeah. This one is the best. All of this possible. We can do many possible way asynchronous code, but with using RX solution, this is the best solution we can write down in RX. So just take a look at this RX solution. This is the functional reactive stream style programming, and here we are using some computations over subscribe and observe on. We still need callbacks while doing the RX. So how we can go better by switching between the imperative and direct style that we can see further.
Now, how many of you are excited to see this code? How many of you understand this code? Just a small raise of hands. Nice. Can we improve this? You want to see how to improve it? Can we do something like this? We write a simple DSL which says load something, give me data, and then render it on UI thread. The UI thread can be show weather, which is a recycler view. I give it a list of weather results for my city, and then it renders it there. As you can see, I have represented green bars there because I really like Kotlin coroutines. The green bars represent that no callback. It's very direct. Now, Vrishali mentioned something about direct style. Direct style is nothing but, we do asynchronous programming, but we write it in an asynchronous fashion. So we do a lot of thread switching. We do a lot of operators in Rx. Debugging that is kind of painful. It's really painful. But if you write it this way, isn't it simple? Isn't it easy to read? Any team member in my team can actually take a look at my code and then work with this, right? Now let's take a look at how this is built.
Are we excited to do this simple kind of programming? Like, not so switching between the imperative style to functional style, just go in the flow, same flow. So that can be achievable with coroutines. So next is, just take a moment to understand what are the coroutines. Coroutines are the way to write down asynchronous code in a concurrent way and in a thread. With coroutines, we can actually write down the With coroutines, we can write down programming in non-blocking manner. What I mean to say is, using coroutines, we can actually start thousands of the threads at the same time, which is not possible with the limitations of threads. And coroutine allow us to write down it in non-blocking manner. Also, we can say coroutine is an instance of suspendable computation. Suspendable, what do I mean by this? Suspendable means stop and continue. Stop and continue, oh, look like blocking to me. Let's see how we can define it in better way. Let's see actually. So here is saying truth can be only found in one place, and that is code. So let's actually see how we can define it in better way with the code.
We are so sorry for the mic. We have to keep doing this. But this fun part is going to start now. So let's take a simple fun experiment. How many of you have written Kotlin here? Okay. How many of you still use Java? Wow. Okay. I think we should give a talk on how to convert Java to Kotlin. Okay. So I'm going to be showing you a piece of code. If you don't understand, I'll also explain it. This is a simple coroutine. It's called launch. It's given by the Kotlin coroutine library. What I'm doing here is going to basically launch a coroutine, print when it started, and sleep the thread for a few milliseconds. And then once the coroutine is over, I'm going to print another statement here, right? I'm also going to print which thread it's going to start with. Similarly, run. Run is available because of Kotlin standard library. This is basically another way of writing threads in Kotlin. So how many of you can actually guess what would happen here? Which line will print first? There are 4 outputs to come. Do you think the run will start first or the launch will start first? No? Okay. Let's actually take a look. We are going to get first run. After that, we're going to get coroutines that are started. The reason for this is because when you write launch over there, launch is going to start lazy. It's not going to start instantaneously. If I have not specified when to start the coroutine. What coroutine does is, I will be explaining how this all works, don't worry. Coroutine starts off by saying, hey, I'm ready. Whatever block of code you want to execute, give it to me, I'll run it. But if you don't specify at what time you want to start, I will start whenever I get the chance. That's why run comes first, and then CR start. Can anyone guess what happens next? Anyone who answers gets a free swag? No? Okay. Next is this. The reason this happened is because coroutine finished first. It's a non-blocking operation. Remember, Vrishali just mentioned that it's a non-blocking way of writing code. We're still doing asynchronous programming. But what launch does here is that it's still using your single thread. Imagine this particular function running on a single thread. It's still using a thread, but it's basically just getting suspended. I'll explain what suspended is. But as you can notice, run takes its own sweet time, 300 milliseconds. Coroutine says, hey, I don't care what you do with the run. I have the resources, I will finish my work. When I get the result back to you, you can then take it forward, right? Now let's take it one step further. How does this all work? Let's imagine that we are in a real world application with single thread. I know a lot of applications right now are running multi-threaded, but to simplify this, let's take a single thread. Now what happens here is, let's say that we have a function a simple ordinary Java or a Kotlin function. You do a very, very heavy task. Imagine talking to your DB, calling network API. There are so many other examples, right? What this would do is it's going to block your thread for the period of time, right? Now, if I have to start another function on the same thread, I have to wait for the thread to become available to me. I have to do something like this. When a function B runs on this thread, again, it's going to block the thread for you. Now, the magic comes with coroutines. Imagine function A as a suspendable function. What this does is, function A does not require the resources of the thread. It's going to start on the thread. It's not going to block your thread. It's going to say, hey, let me start. You can do whatever you want on the thread. Thread is still available. You can have function B then run its course. When coroutine wants to return, it can return and give you the result back. It's as simple as that. We will actually take a look at what suspended is. Similarly, you can start multiple and thousands of coroutines. Coroutines has been there since a long time. It's not just because Kotlin coroutines is out. It's not because of that. It's been there since a lot of time. So this is our agenda for today. We're going to be discussing how coroutines work. But before that, we'll also take a look at each of these components to get you apprised of how to write coroutines.
So these are one of the components. We have not covered all the components over here. So I would like to start with continuation. While talking about continuation, before starting the continuation, coroutines inherently async and continuation, whenever we talk about coroutines, continuation plays very important role under the hood. So let's to understand this continuation better, let's take a real life example. So let's say you and me are unknown persons. We are meet together somewhere. We are just talking about something, discussing something. And again, when we meet next day, we are just gonna start or hit the conversation. We are not re-establishing the context, or we are not giving the context on what discussions we have done yesterday and what we have talked today. So we are just starting from the point where we left yesterday. That's where the continuation comes in. To compare that with the function. So let's say if the function has some return type, and it could also tell us where it is coming from and what they are returning. So if the call side of the function want to communicate that function, it could just resume with the state. So continuation is nothing but an interface, and it could represent the state of the program. That's what the continuation means. Let's take a look at next coroutine component.
Okay, so let's actually take a moment. Let's actually understand continuation again, but let's take a simple code, right? How many of you know what builder pattern is? What does builder mean? Builder is nothing but I give you a parameter, initialize an object with it, and then proceed and give me a copy of it, right? Similarly, within Kotlin coroutines library, we have few builders, really popular ones. With context, what this does is it returns the answer back to you. So if you're doing some heavy operation, the return type is returned immediately. So you can basically call with context and assign it to a variable, right? Let's say that you're doing list of weather, then the list of weather data class is returned back to you. There's one problem here. You may have to handle your exception because this does not do anything with it. So in RX, what would you do? You would do on error or resume on next, right? What would that do? You would basically be handling your exceptions. What coroutines builders do is they basically run the code. How continuation comes into picture here is when you start a coroutine will take that continuation interface. It's going to say, hey, I'm going to do some task with it. You give me the context of where you want to start, right? Context is not equal to application context. Context over here is a coroutine context. We will come to that. Now what this does is, within the with context, you can say, I want to run this block of code, right? I'll give you the return type. It's basically writing a simple function and saying return t, right? Similarly, we have launch. What launch does is basically does not return anything to us. It just gives an object called job. How many of you use job schedulers here? Okay, the rest of you, please start using job schedulers. Don't do, in your application, if you're running a very heavy task, don't do that. Don't write any, basically don't even use async tasks. Please try and start using job schedulers. Similarly, with how you do jobs, job over here would basically say, hey, I'm going to start a coroutine. Like, I'll tell you, hey, take your swag from that table back there. I don't care if you have done it or not. It's my job to tell you that you can do something there, right? So I'm a coroutine where I fire my statement and I'm done. I don't know what the result would be. I don't know if you want to take your swag or not, right? So that's how launch works. Now, again, you have to handle your exceptions here. It's not going to handle it for you. It may crash if you don't handle your exceptions. Similarly, we have async, where we get an object called deferred. Now, also one more thing to note here, this is still running Kotlin experimental. We're not going to be covering the stable yet, but in the stable, async is no longer available. But to explain how this all works, async does this. You say, hey, I'm going to run something for you. I'm going to take a bunch of tasks that I want to complete. I'm going to start it in a coroutine. Now, async will then take that and complete the task and give you an object called deferred. Deferred is basically a promise in JavaScript. Like, okay, I'll take 10 minutes, I'll take 12 minutes on device A, I'll take 5 minutes on device 2, right? What deferred does is it's going to say, hey, I'm going to promise you're going to get a result or an exception for it, right? Again, you have to handle your exceptions here. Now, let's actually take one simple example and run you through how it all comes together. This is an actual code within the Kotlin coroutines library. What this does is, the keyword is very simple, launch a coroutine, right? It's a simple builder. Now what this does is, the first parameter, default dispatcher. This is a Kotlin syntax for writing default parameters, meaning you don't have to mention any of these, you just have to mention the last block of tasks that you want to run. Parameter 1, 2, 3 is not required. You can specify it, but it's not required. Over here, default dispatcher or coroutine context is nothing but it's telling the coroutine, hey, this is your task, do it in this thread, or do it in a pool of thread, right? You can basically, there are multiple of dispatchers here. If you go through the Kotlin guide, you will see that we have, you can start it right now, you can start it lazily, you can start it on main thread, background thread. There are quite a few available within the library. Similarly, we have coroutine start. This is a really fancy way of saying you can start it right now or you can start it lazily. So in Kotlin, we have lazy delegations where you can say, hey, I'm going to initialize this object after a while. I mean, it's not going to be initialized when the program runs. I may need it after a button click or something. So similarly, you can declare something like default is basically start right now, or you can say lazily. Now, I didn't go over what a job is again. So job is over here is going to be returned by the parent, right? So let's say that you have a child-parent relationship where you have one coroutine which starts within another coroutine. When you basically start the second coroutine, parameter 3 is auto-initialized for you. It gives the context from the parent to your child, all right? Now, at the end of it, this is a Lambda operation where you give it a block of code that you want to run, and it will run for you. If you notice, we have a keyword called suspend here. You can only call a coroutine with a suspendable function. If you do a normal function, then it's no point. Launch is just another block of code running on its own. And finally, every coroutine that you can see here with launch gives you a job or a T. If you remember from the previous slide, we had with context, which returns a result back to you. But with launch, you get a job. With that, let's actually look at what a suspend function is.
Okay, so suspend is the one of the keyword from coroutine library, and suspend means you can start, resume, and stop at any time. Let's take an example of suspend. Let's take this simple example of load weather. So load weather function is doing some heavy network operation. And let's say it's returning response in a result. So what will happen internally if you add suspend keyword to this function? Anyone who have studied coroutines know the answer? Yeah. So, okay. This suspend, once you add suspend to the our normal load weather function, it will transform to transform our method signature to this odd thing which we are seeing over here. What is this odd thing? So this odd thing is nothing but your load weather function is no more returning a result. The result is taken by the continuation function. What that means is, that means continuation will actually take care of your result and it will carry forward it to the child coroutine or the parent coroutine. What continuation will say? Hey, what continuation will say? It will say, hey, it's not need to return result right and right there. I will just carry forward it and I will return when it is required. And continuation, so when you add the suspend keyword, you need to do anything by yourself. It is taken care by the Kotlin library. To understand this bit more, let's take another example. Let's say you are writing down Fibonacci series example and you want some result. So you have provided some n numbers and you want some result in list of the integers. So if you add suspend to that Fibonacci function, what will happen? It will not return the list of integer then and there only. It will just carry forward the result to the coroutine builder and it will return when you required. That means it will not block the thread. Next component is coroutine context. As Adit already mentioned in launch coroutine builder, there is first parameter that is coroutine context. What is coroutine context? Coroutine context will is not an activity context or application context. It is it will actually help you to write down coroutine and it will help you to run the coroutine in concurrent thread or concurrent execution. So these are these are two coroutine contexts we have used, UI and common pool. Coroutine context inherently extend the coroutine dispatcher and it will responsible to tell the thread or coroutine to run on which thread, that is background thread or the UI thread. So mostly common pool is the default thread which is shared across all over. We use generally as a default, or we can specify that this coroutine should work in background thread or this coroutine should work on UI thread.
Okay, so we have done some really okay theory, right? It's early in the morning. We actually want to see what we're going to be doing with our code. So the plan is we're going to start a coroutine, talk to our API, something like server.await, meaning that I have to wait for my server to give me a response back. Finally, we're going to parse the data because ultimately server would it'll return success, errors, a lot of data that I don't want to show. I'll only need a bunch of it. Finally, we're going to display it in a list. Also, as a fun trick, I'm going to show you how to do it in DSL. Remember the fun and easy solution I showed you before? That's what this is for.
Okay, so let's take an example of the coroutine with launch. Here we are using background coroutine context, and whatever data we are fetching with the API call in load weather, we are saving it in weather result, or we are assigning it to the weather result. So what are this background context? It is a coroutine context, as I already explained you in earlier slides. And this launch is nothing but the coroutine builder. That's what we are talking from the first of the talk. So the plan is we are actually fetching we are actually fetching the load weather from the network using the common pool coroutine context, and once that that is finished, we are showing it in the show weather function. So till the time we are not getting result from load weather, we are not actually switching the coroutine, and we are not showing the result in show weather. So for showing weather, we have extend another coroutine, that is launch. So let's take an example to explain this slide. So how many of you use async task? All of us, yeah. So whenever let's imagine you have write down this code in this coroutine in activity, and activity dies. What will happen with the async task, traditional async task? App will crash, or activity will still leak the context because it is a async task problem. So with coroutine, what will happen? Coroutine will provide the job, and we can save that leaking of activity by doing the job.cancel. Yeah.
Sorry, I just want to mention one more thing. When you do something like this, as you can see, I have a parent coroutine, launch context common pool. Common pool is nothing but a pool of threads. There's a formula for it. If you go to the standard lib exercise for you, please go through and understand what common pool is. Second, when you say job.cancel, how many of you know what would happen here? Okay, except Rivu. Sorry, Rivu, you're expert on this. What would happen here is that, let's say that we have nested multiple coroutines, talk to API 1, talk to API 2, talk to API 3, combine all those results and then show on a UI thread. Let's say that one coroutine throws an exception. So if an exception is also not thrown, if the success is available, what if my activity dies? What would happen is then I can put this job.cancel in my on destroy, meaning I don't want to listen to this anymore, right? So that way you are still saving resources. With that, let's take this example a little more further. Let's make it even more fun for you guys. Let's write a simple thread switching example. We have been seeing how to do thread switching with Kotlin coroutines, but let's actually take it one step further. Let's also build a simple DSL around it. Our DSL stands for domain-specific language. What this does is it's basically writing your syntax in a much easier way that you guys can understand, right? Instead of following whatever the API is providing you. API here is nothing but the library. And third, we're going to be dancing with a final code. I literally jump every time I use this coroutine, right? This is our solution. It looks kind of complicated, but it's not, to be honest. What we're doing here is, I'm going to be calling this function called getWeather from my main activity. I'm going to be starting a coroutine in my UI thread. The UI in, okay, purple, the color is changed. The UI over there is nothing but a coroutine context. It's telling my first coroutine, or the parent coroutine, to start it on the UI thread. Within that, I'm saying view.show loading. Right? Yes? Okay. Next, we are saying, hey, take this context called background thread and do something for me. That do something for me is nothing but a load weather. Now what this does is, it's going to suspend. This function load weather is a suspended function. That means nothing below it will be executed, but it's a non-blocking operation. Meaning show weather result will not be executed until I have my result. The result is nothing but my variable that got assigned. With context, if you remember from previous slides, it's returning you the result. Now, all this looks fun and fancy, but I'm still not very happy with this. Just to also summarize, this is what my load weather looks like. If you notice, I have added the keyword called suspend. It's basically talking to a repository class, doing some heavy operation, like talking to a network, computing data, and then returning a result back. Similarly, we have show weather, if you follow MVP, MVVM, right? But this solution has been kind of not so fancy, right? We were over here, right? We used to do this. Now, we're on this. this is still a lot of lines of code for me. I would prefer to write it in a much simpler way so that my LOC is less. My PM is happy that I achieved my task much faster. Let's take a look at how to do that. Now, I'm going to be using two very specific things. This is called higher order function. The first line of code that you see is a simple function with a keyword called suspend. I'm passing in another function to it. What higher order function does, it's also available in Java, by the way, Java 8. What this does is it's going to take one function, pass it as a parameter to another function, and execute that for you. All right? This is a Kotlin thing. It's very simple. I just return the block, and basically the block is nothing but another coroutine, right? What this does is it's going to return a deferred object. Deferred is, again, async in our example. Now, similarly, I'm going to be writing another extension function. Extension function is nothing but adding a property or a function to an existing class. Now, what this does is it takes the deferred class. Remember, I can't manipulate what library gives me, but I can add functionality on top. Now, what this does, it takes the deferred object, and then I'm writing a function called then_on_UI. I take a block of code or a function that I want to do when this function is called. Now, what this would do is it's going to launch another coroutine on the UI thread and then call that function for you and await for the result. Yes? Now, let's see this in action. Ta-da! Isn't it simple? We wrote 7 lines of codes in our first solution. We are able to achieve this. If you notice, there is no continuity here. This is direct style of coding. When I say load and then on UI, it is basically firing 2 coroutines. One parent to talk to your API, second to get the result, await for the result, and then show it on your thread, right? Now, many of you have a doubt. How do we go about using coroutines in production? We've been using the non-stable, the experimental coroutines at Gojek for a pretty long time. We have found a lot of issues here and there, but it's very, very production ready. The stable coroutines is also out. We are not going to be covering here, but we are also going to be talking about how to handle exceptions. To handle exceptions, we have the famous try-catch block. You can actually write a try-catch block and not be screwed by your tech lead. You can actually write a try-catch block here. Or if you're really smart about it, you can use something called coroutine exception handler. Now, how coroutine works is that it connects to your thread, literally connects to your thread. If you don't write a exception handler, it will default to the thread's uncaught exception handler. So if you don't write this particular piece of code, whatever happens with your coroutine, if it throws an exception, whatever thread you're doing it, it'll get fired on that. So a thread has an uncaught exception handler. All those illegal state arguments and all the crashes that you see or all the exceptions that you see, your thread is catching those. So if your coroutine does not have an exception handler of its own, it will default to the thread. But if you really want to be custom and smart about it, you could do something like this. I can write something like, I'll declare a class called, custom class called coroutine exception handler. I do a println, I can do use timber, log, whatever, right? And finally, I can do it something like this. If you notice in the coroutine builder, I am doing launch handler. What launch handler does is it's saying, I'll give you the context, run it in the UI or background, whatever you want, but whatever exception comes, throw it to that guy. That's it. That's what it does. So if I throw an assertion error here, it will not go to your thread. It will not go to your default thread exception handler. It will go to this and print it. It will not crash your app. Cool? And with that.
So till now we have saw code, we have saw concepts of coroutine. We studied these coroutine concepts and example from resources over here. You can actually go ahead and play coroutines in your go to playground. Also, there are some very good talks on YouTube. You can watch that and understand what really happens while continuation and suspend we use in our coroutines. Yeah, that's it.
If you have any questions, we have enough time actually. We actually ran through a lot of things. If you have any questions. Yes. Just one sec, just hold for the mic. Oh, okay. Let's actually take that and then, sorry. Yeah, please.
So you said that in one of the examples you showed a job running, right?
Yes.
You said that you need to manually write job.cancel, otherwise.
See, it returns a job. It's up to you to start, resume, and stuff. What if on pause you want to pause the particular coroutine? Let's say it's not a network thread. You're constantly talking to a socket. You want to pause that for a while. The job gives you that functionality.
So, but let's say I'm making a network request or some big process, and I use a coroutine to start that particular process. If I don't cancel my job, but the activity dies, and I have not called job cancel, does it still actually leak?
It will actually. Because I have been specifically mentioning in one of the slides where I showed you builders, all unhandled exceptions will gonna crash. You have to handle it on your own. So if you write a simple coroutine like launch, talk to my API, if you don't wrap it in a try catch, or if you don't put a handler, exception handler, your app will get an exception saying, hey, if you remember the continuation interface, a slide where we showed, we have 3 parameters, context, resume, and resume with exception. Yeah. What resume does is it's the success callback. What resume with exception is, it's going to give you a throwable that happened within the coroutine. It's not going to give you the result, but it's going to give you the exception. Yeah. So you have to handle that. Yeah, someone here. Yeah. Oh, sorry. Let's get you a mic. Yeah.
So I have 2 questions. First is, what is the default context when you use the launch?
Default is nothing but, for context you mean?
Yes.
Default is just going to say, hey, I'm going to start with whatever thread, the common pool. So if you don't specify a thread, it's going to take the common pool.
Background common pool.
Yes.
Okay, so the second one is, so sometimes in the code, right, you give the context as UI.
Yeah.
And there is a function called run on UI.
Yeah.
So is there a difference or both are same?
See, run on UI thread is nothing but just taking whatever piece of code you want to write and running it on a thread that is declared as a main, right? It's main thread. But with coroutine, UI, so you get something called Kotlin X experimental Android extension for your coroutine. So UI is coming from there. It just delegates the coroutine back to your UI thread.
So if you're using it inside the launch, it's basically do the same thing as the launching is.
Yeah.
Okay.
Yeah, one there.
Hi, Adit.
Yeah.
Great talk. Just one quick question. Is the job an equivalent to a disposable?
To an extent, yes.
So let's say if I have multiple jobs or multiple coroutines running in my view model,
Okay.
and if I want to responsibly dispose them off in the on-destroy somehow,
You
how
can
do I do that?
You can basically, so let's say that you have a parent coroutine, right, which is running other coroutines internally, like a parent-child relationship, and you want to cancel one of the child coroutines, right? What would happen is you can write, let's say that you use a launch, which gives you a job object, or if you use async, which gives you a deferred. Deferred is nothing but an, again, extension of job, right? So when you use that, what will happen is you can basically, whatever the job object that you get, you can make it as a global object, and then you can cancel whenever you want.
No, that's clear. But is there any equivalent of composite disposable?
No.
So you'll have to manually just
Yes.
cancel all of the jobs.
Yeah.
Okay, good. Thank you.
Any other questions?
On the same note as what you just said.
Sorry, yeah.
So, wouldn't it be more efficient if, the Android library has specific life cycles? Everyone knows there's on stop and all that. Would it be more efficient if the code?
Actually, so we had 6 minutes, but we could have done that too. With keeping time in mind, we didn't actually show you some more fun DSLs. You can actually write a lifecycle owner from the activity lifecycle components. You can basically take the continuation interface and say, hey, if my activity dies, cancel everything. You can do a lot more with writing a own lifecycle owner. You can basically customize it.
But even that you have to do it manually, right? Wouldn't it be better if that was part of the coroutine library? Because most people.
So if you do realize this is not just specifically for Android, it's also meant to be a multi-platform thing, right?
I know that.
Yeah.
But when
So
using the Android version of it, I think it would be more efficient because most developers
Makes sense, yeah.
will forget to write a.
makes sense, yeah. So see how coroutines, you have to be, so like, if you use RX and you want to, you get fancy with the slides and you say, hey, I'll try coroutine today. Don't do this on production. Actually put your effort and time in understanding what coroutine does. Coroutine solves a lot of problems, but also doesn't become a reactive stream like RX. right? So you have a lot of things that you can do with coroutine, but it doesn't make sense to just use it just because it's fancier API, right? So coming to your point where why don't the library itself provide you a function like this? It may be coming soon. It may be available in the stable yet. So far, I haven't, to be very honest, I haven't tried stable yet. Yeah.
So just, it's not very related, but
Sure.
you said that async will be gone, right? Right now it's
Yeah.
experimental.
Yeah, okay, so I'll give you a little more about what is coming in stable. So when stable comes out, it's basically launch and async is totally gone. You have to now extend something called global scope, coroutine scope. You're telling the scope or the class that's going to handle your coroutine and saying that, hey, this is what I'm going to be doing. This is what I'm going to be getting a result out of. I'll give you the context. I'll give you the control. And when you write async, it's now available because of coroutine. It's an extension to the scope class. So you cannot write just async anywhere. You have to say what scope you want to run it. It will define the coroutine context for you. With the lack of time, I could not do much on the stable. But if you're looking forward to trying this out, there are a lot of resources that we have put on our slides. You can go and check it out. There are a lot of great videos out there. KotlinConf just got over a week back. Please go and see Venkat Subramaniam's talk. He has done it beautifully on that.